Ask me to write the difference. Ask you to write down the difference between mixtures and compounds.
Yeah. Yes, ma'am.
Done now. Show me your book. Ah. I told you to write this. Homogeneous and heterogeneous.
Yes,
Yeah.
ma'am.
Homogeneous heterogeneous.
That was what I did. Extra one mixture and compounds. I asked you to do for homework. For homework, I asked you to do. But where are you doing it? Something you're doing. See, you're doing physics. You're doing chemistry.
Yes, ma'am. From that, that was the last page of physics.
So
From
you're doing
now.
some math here, something.
No, ma'am, that's physics. But from now, I'm using that one before chemistry and physics and biology.
Okay. So last time I think I understand. I don't know whether this is coming or not. Right? You not come?
I have exams. Exams are doing.
In the school?
Yes.
Right? So we are talking about solutions. What does the solution consist of?
Solvent.
Solvent, yes. So you have a solvent and a solute. Okay, so it all depends upon how the solute is dissolving in the solvent and it forms a solution. Okay. Now when you look at solution, we know that these are two things very, very important because it helps us to understand whether it is a dilute solution or it is a concentrated solution. Suppose I tell you that it is a dilute solution and the other one is a concentrated solution. How can you actually look at it? Okay. One is visually. For example, let me just give you an example. Suppose I take a beaker and this is beaker number A and this is beaker B, and in both I'm taking the same amount of liquid. Let us say it is 100 ml of water. Correct? So both of them, we have the solvent which is the same. But now we have to dissolve, we have to understand regarding the solute. In one, I'm putting copper sulfate, and in the other one also I put a concentrated copper sulfate. Copper sulfate is a typical blue color, okay, crystals. So when you dissolve it in water, the solution will become blue. But now I'm saying it's a dilute solution and it is a concentrated solution. Let us see what is the difference. Here I'm putting only 5 grams of copper sulfate. Here let me say I'm putting 20 grams of copper sulfate. Did you understand the difference now? Why has it become a concentrated solution? Visually you can make out because this color will be much blue, dark blue. Here it will be light blue. Okay, so visually you can make out that it is a dilute solution and it is a concentrated solution. But then many times this physical change you cannot make out because many of the salts are colorless. It's almost white in color. Right? So when you are putting it in a solution, how can you make out whether one is a dilute or a concentrated solution? We have to specify the mass. Right? Here again I have taken a common solvent in both the test tubes or both the beakers is the same. What if I change the solvent? What if I change the solute? So it becomes very difficult. For example, let me say, here I have taken, let us say 51 ml of water. Okay, I'm just giving you some number. Here I have taken, let us say 73 ml of water. Okay, some odd number like that, instead of taking 100 ml in both the cases. And even this, instead of taking 5 grams, I'm putting something like 12.7 grams. Here I'm putting something else. Okay, for example, I'm putting 18.6 grams. How do you know which is a concentrated solution or how do you know it is a dilute solution? So you understand? If we have both the solvents the same, then maybe you can compare and tell whether this is a concentrated or a dilute solution. But now my solvent is also different, my solute is also different. So obviously we cannot make out. So if you turn the paper, look at you, how can you actually find out the concentration of the solution? Page number 16, 16. Concentration of the solution. 160, get it? So there are different ways by which you can find out a concentration.
NCRT or NCRT?
Okay, so you have there on the other side 16 and 17.
Yes.
On page number 17, you find two formulas. Okay. There are different ways of expressing the concentration of a solution. Okay, one is mass by mass percentage. So one particular formula is mass by mass percentage. What does it tell us? We are comparing the mass of the solute to the mass of the solvent into 100. Okay, so this formula tells us mass of solute upon mass of solvent times 100. So what does it tell us? It gives us the answer in terms of percentage. Did you understand that? Okay. Now, mass of the solute in this particular case is how much? 5 grams. Let's take only weaker one. Mass of the solution mass of the solution. Now, what does the solution contain? Contains the solvent and it also contains the solute. Okay, so we have to add up 100 plus 5. Did you understand? Okay, so mass of the solution will be the total mass of the solute and the total mass of the solvent. Times 100 is obviously because we are comparing it in terms of 100. Now let us look at this example that I have given. Is it easy for us to understand? How much is the mass of the solute here? 12.7 grams is that of a solute. What is the mass of the solvent?
16.7 grams.
Solvent is 51. Total of the solution is what? This plus this. Correct? Because we are talking about the mass of the solution is equal to solvent plus solute. Now, another thing that you will notice is I'm talking in terms of ml. What does ml tell us? X ml, something x ml. Is it mass or is it volume? It is volume. Correct? But now I'm talking about mass. Correct. How do we convert? I've taken water. In this case, I have taken water as my liquid, that is the solvent. Think. Are you familiar with this formula? Density is equal to mass upon volume. Do you know that? Density is equal to mass upon volume. Okay? No, not familiar. So from here you can easily make out, if I want to calculate mass, what will I do? Mass.
5 grams.
So from this equation you will understand mass is equal to volume times density. Correct? Okay. So if at all it is given in terms of volume, you just have to multiply it with density and it will give you the answer in terms of mass. So that is good. So here if at all it is given in mass, then it is equal to so many grams. No? Clearly, did you understand? Now, the speciality about water is the density of water is 1 gram per cc. Okay, so what is the density of water? Water is 1 gram per cc. Cc is ml. Okay, so the answer will be mass and volume, both of them will be 1. Did you understand? When I say it is 1 gram per cc, density is equal to 1 gram per 1 cc. 1 gram is your mass and volume is equal to 1 cc, which is equal to 1 ml. Okay, so for water, because it is 1 gram per cc, then it becomes very easy. For example, if I say if it is 51 ml, it means it is having a mass of 51 grams. Is that okay? Come on, take out your notebook, copy down this.
How many exams should we get energy chemistry?
They will give you the density. They will give you the density. The topic will be concentration of solution. If you have not done your homework, please leave that page. I want you to do the homework. Abhishek, you have not done. Please write it down. Leave the page. Write your homework. I want everybody to write it as he has done and all of you have not done. Difference was mixture and compound. Write it, otherwise you forget again. Homework was difference between. Copied it now. You've written it down. What have you done? Show me again. Okay, concentration of a solution. Right? The concentration of a solution. The concentration of a solution is the amount of, sit down properly, beta. Is the amount of solute present in a given amount of mass present in a given amount of mass or volume of the solution. Okay. Okay. Now what does it mean? It's a statement which basically is asking us that we are comparing the mass of the solute to either the mass of the solution or even the volume of the solution, as the case may be. Okay. Another very important formula which I told you right now is write down this. It may not be given in your textbook, but write down very important. Density is equal to, write down this formula. Density is equal to mass upon volume. Okay, using this you can also find out mass is equal to volume times density. And another very useful information that you need to know is the density of water. Write down this also. Density of water is equal to 1 gram per cc. What does it mean? It means this. Density is equal to 1 gram upon
You can
1.
write D.
D is for density, capital D. Here also you can write D is equal to M upon V. Okay, but initially you write the complete word because you do not know what it is. Is that okay now? Okay. Now you see there is an example 2.1 in your textbook. Okay, so we are trying to use the same formula and we are going to see how we are going to work it out. What is given to us? Will you do it now? Right now? Okay. A solution contains, first of all, we are trying to read the sum, understanding what is given to us and what needs to find. Right. A solution, come on, somebody read it out for me. Yeah.
A solution contains 40 grams of.
Okay, now as we are reading it down, you are also going to write it down in your notebook. A solution contains 40 grams of common salt. So what is it? 40 grams of common salt, which is sodium chloride. What is this? Is it volume or is it mass? Mass. It is in grams. Okay, so obviously it is going to be mass. So mass of, is it solute or solvent?
Solution.
Is it solution? 40 grams of sodium chloride.
Solvent.
Solvent is the liquid. Solute. So mass of solute. That they have given as 40 grams.
Mass of a solution contains 40 grams of common salt and 320 grams of water.
Okay, now let's understand. What else have they given us? They have given us 320 grams of water. Now they are giving water. Is that solution or solvent? Solution. Solvent. Okay, so this is so. And it is in grams. So obviously it is this is mass of solvent.
Where to write this question?
Calculate
Yes.
the concentration in terms of mass by percentage of the solution.
Okay, so we have to find out. What are we finding out? We have to find out concentration which is in terms of mass by mass percentage, to find out concentration in terms of mass by mass percentage. This is what we have to find out. This is not given to us. Now, using these two, what is the next thing that we have to do? Obviously, we have to know what is the formula because they are asking you mass by mass percentage. Correct? So, first one is mass of the solute divided by mass of solution. Are they given as mass of solution? They have not given mass of solution. But can we find out from this information? Yes.
What mass of solution they are given?
Solution. Solution is not there. So how can you find out mass of solution? Mass of solute plus mass of solvent. Okay, using this data we can write down mass of solution 320, 40, that becomes 360 grams of solution. Next, I want you to copy down the formula. Copy down this formula.
No, I've copied.
Here, right now, below each sum, you have to do it. A sum must have your formula. You wrote down this data.
No, sir. No, I have started.
You wrote this. You wrote this. Write this. Write this. Down. After this, you write down the formula. So what is the mass of solute here?
40 grams.
40. What is the mass of the solution?
360 grams.
360.
Oh, sorry.
Okay. In times 100. So if you work out, you will get your answer. Answer will be what? Is it grams? Is it ml?
1 gram per cent.
That is density. I'm not talking about density right now.
Grams.
What is your question? In mass upon mass percentage. So whatever number you get here, this will be in percentage. Okay, because you've already multiplied it with 100. But you can do it afterwards. Cancelling your. This is nothing but pure math. Have you followed how it has to be done? Did you follow?
Yes.
Yes. Suppose we change the numbers here, you will be able to do it, isn't it?
Yes.
Right. It's easy for us to do.
This addition and formula.
Yeah, use this formula, whatever is given here. Substitute it here. You should be able to get the answer. Finished? Answer then given 11.1. So you do the long division, you will get the answer. Last time I had already spoken to you about the solution. What are the two types of solution? What are the two types of solution? Correct. What are you still working on, finish? Write down the answer. See, if you do it the long way, you will get it. Now we are come to the next part. So what is it? What are the two types of solutions that you get? Homogeneous and heterogeneous. Write down the answer and read it. I don't want you to waste your time reading it. This I had already explained to you, isn't it? Homogeneous and heterogeneous. Look at your notebook and tell me what is the difference between homogeneous and heterogeneous.
Uniform composition, non-uniform composition.
What are we? What we?
Homogeneous, uniform composition,
Composition.
heterogeneous, non-uniform composition.
Okay, what is the example that we have got?
Homogeneous, for example, sugar in water, sulfur in carbon dioxide solution.
Sulfur and carbon dioxide solution is a homogeneous. Yes, that is there. Another one?
Alcohol, etc. Sand, water, oil, and water.
Yes. So that's
Sand and water, oil.
So if you take sand and dissolve it in water, obviously you know that it is not going to dissolve, so it becomes a heterogeneous.
I have written sand and salt.
Yeah, the sand and salt is
No, sand is
Solution because we require a solvent.
heterogeneous is
It is heterogeneous, there's no doubt about it. It's a mixture. It's a mixture. Okay. What did you write for homogeneous then? What have you written?
I mean, homogeneous is wrote salt, water, and sugar.
I wrote both same in both like salt, water,
okay,
sugar,
okay.
water.
So you know that salt and sugar water will come under homogeneous. Under heterogeneous, suppose you put sand in water, obviously you know. Or chalk. Yes, or put you chalk, take chalk powder and you put it in water. After some time you know that it is going to separate. So in a heterogeneous solution, you have got two separate layers. Okay. Now today we are going to talk about what is a suspension in your textbook. Right? Virat, you can read it. Are you read?
Non-homogeneous systems, non-homogeneous systems, like those obtained by Group C in Activity 2.2, in which solids are disposed in liquids, are called suspensions. A suspension is an heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk.
Underline that. What is a suspension? So a suspension is nothing but a heterogeneous solution.
Throughout the bulk of the medium. Particles of a suspension are visible or to the naked eye.
Is it true? If you put mud in water, sand in water, can you see the particles? It is visible to the naked eye. Okay. And it forms two distinct layers or two different portions which allow the particles to settle down. Now, what are the important characteristics of the suspension?
Properties of suspension. Suspension is a heterogeneous mixture. The particles of a suspension can be seen by the naked eye. The particles of a suspension scatter a beam of light passing through it and make its path visible. The solute particles settle down when a suspension is left undisturbed. That is, a suspension is unstable. They can be separated from a mixture by the process of filtration.
Okay. Did you understand what is the process of filtration?
Yes.
How do you do filtration? How can you separate out sand?
Like pen.
You take filter paper.
Yes.
Okay, you put a conical glass. You take, let us say you are having, okay, a beaker and you are having some sand particles. Now I want to separate out the sand from water. So what do I do?
We'll take one another picture.
Yes, you take a conical
Then
funnel
we'll,
and you line it with a filter paper. And then you pour this whole thing here. Okay, so what will come out here? Water. Solid pure water. What will settle down here?
Sand.
That is the process of filtration. So what are the characteristic features of a suspension? Now write down. I'm not asking you to write down fully all the 5 sentences. I'm giving you the key words for which you should remember. Write down. Your topic will be suspension. First point. First point. It is a heterogeneous mixture. First point is heterogeneous mixture. Second point. Particles can be seen with naked eye. Particles scatter a beam of light. Can be seen with the naked eye. Third point is, second point is they can be seen with the
Particle
can be seen with a naked eye. We can just see the particles. Third one. Okay. Particles scatter a beam of light.
particles scattered.
Beam of light. Beam of light. Okay. Next one. Solute particles settle down. Solute particles settle down. When? If it is left undisturbed. If it is left for some time or if it is undisturbed. Correct? And the last point, how can you separate? What process? Filtration. Can be separated by
By the process
filtration.
of filtration.
By the process of filtration can be separated by filtration. Is that okay? So you notice here the 5 points that they have given in your textbook. Look here. See, this is point number 1, 2, 3, 4, 5. Okay. So I've just condensed it and I've given you the important word that you have to use. Put a tick mark here in your textbook. What is a suspension? I have given you all the 5 points. Correct. 1 and 4. And I'll split up the last one into how it can be separated. Okay. Point number 5 is
Example, we can write by our words.
but I want you to use these words. These words must be present.
These also.
These are the key words. So you can write down these things, but sometimes children find it very difficult to learn the answer. They can do write the answer, but these words are very, very important. Okay, come on. Next is I'm going to talk about a colloidal solution. Did you see the next one? Now you see I'm going to talk a little more in detail regarding heterogeneous solution. Okay, so when we are talking about a mixture solution, homogeneous or a heterogeneous solution, heterogeneous, of course, it's definitely a mixture, and it is now we are talking about a suspension and a colloid. We have seen an example of suspension. Now we are going to see what happens in a colloid. Now the particles of a colloid is much smaller as when compared to a suspension. For example, if you take a beaker of water, okay, and put a few drops of milk in it, okay, that becomes a colloidal solution. So a colloidal solution appears as if it is a homogeneous solution. You cannot make out the particles are separate. It appears, but in fact, what is it? It is actually a heterogeneous solution. Can you see that? So which particle is the smallest? Homogeneous or it is heterogeneous? Can we see a homogeneous, the particles of homogeneous? For example, salt, you cannot see. So the smallest particle is that of a homogeneous. Heterogeneous, can we see the particles? We cannot see the particles, but it is heterogeneous. Did you understand?
We can see it.
We cannot see this. We cannot see the particles of a colloidal solution. Okay? Suspension, can you see? Yes. Sand and water?
Yes.
Definitely, yes. Okay, you can see it is visible. Then how can you make out the difference between this homogeneous and a colloidal solution? Now that is where we are talking about something which is called as a Tyndall effect. I just want you to see this. Oh, it is such a small one. What? This one?
Right. You can see that 100% in that left. You can see.
Yeah. Okay. But it's okay. It's not pixelated. You can see that, no? Can you see 3 different type of? I'll read it for you. First one is solution. See the board. This is a true solution. Next is a colloid and a suspension. Okay. The light beam is not visible. Now, what are we doing here is we are passing a source of light. Okay. In a pure solution, the light particles are just passing through. But in a colloid and a suspension, you can find the beam of light passing through. What is happening? Suppose you have taken water and you have put a few, colloidal particles, like for example, as in milk, a few drops of milk. When light falls on it, it is getting scattered. So it is coming back at us, and that is how this beam of light is visible in a colloidal as well as in a suspension. So what is the example here? Water, that is for a pure solution. Milk, here it may be flour and water, chocolates and water, it can be sand and water or whatever it is. So this basically is what is known as a Tyndall effect. Tyndall effect is what? So named after the person. Yeah, did you see this? Okay, it becomes more visible if you have got a very narrow beam, like the laser pen that he's having here. What solution is this? It is a solution, it is a homogeneous one. What is it? It is appearing to be. It is heterogeneous. It is appearing to be homogeneous. But is it homogeneous? No. Is it colloidal suspension? It is colloidal solution. Because in a colloidal solution, you can find the beam of light. Is that
Now we
clear?
can find a beam of light in suspension also.
Suspension, yes. Suspension also you can find because there are particles, no? As long as the beam of light is having some particles which is capable of reflecting the light back here, you can see it. Is that okay? Okay, fine. Read now. Anybody wants to read? Read. This. Now we are going to talk about colloidal particles or colloidal solutions.
The mixture obtained by group D in activity 2.2 is called a colloid or colloidal solution. Colloidal solution. The particles of a colloid are uniformly spread throughout the solution.
See, did you see that? The particles are uniformly spread. If I keep a solution of a colloid for a very long time, will the particles settle down?
Yes. No.
It will not settle down. It will not settle down. These particles will still remain there. That means it's a very stable solution. But what happens to sand and water if I keep it in after sun? All of them will settle down. Okay, that is an unstable solution. Read. Did you underline that? Did you underline? Uniformly spread. The particles are uniformly spread. Yeah.
Due to the relativity, smaller size of particles as compared to that of a suspension, the mixture appears to be homogeneous.
Underline. What is the key word here? It appears to be homogeneous. Is it homogeneous? Is it homogeneous? No. It is appearing to be homogeneous. Why is it happening? Because of the small parts. Yes, small parts. Now, which size is bigger? Colloidal particles are bigger or solution particles are bigger?
Colloidal.
Yes. Okay, so the smallest will be for what?
Homogeneous.
Homogeneous. Next will be
Colloidal.
colloidal. Next will be
Suspension.
suspension. Very good.
For example, milk. Because of the small size of colloidal particles, we cannot see them with naked eyes. But these particles can easily scatter a beam of visible light as observed in activity 2.2. This scattering of a beam of light is called the Tyndall effect after the name of scientist who discovered this effect. Tyndall effect can also be observed when a fine beam of light enters a room through a small hole. This happens due to the scattering of light by the particles of dust and smoke in the air.
Okay, now just imagine this room, you have put black curtains all over, okay, and you have got a small opening in the curtain or whatever it is. Can you find a beam of light coming through? Yes. Okay. Why? Because there are dust particles which we cannot see with our naked eyes. But when light is falling on it, it is capable of scattering the beam of light, and therefore you are able to see the beam. Is that okay? Same thing happens even in the cavity of forest. Look at the picture which they have given in the next one. You see, there is a thick forest. Okay, and you can see the beam of light there, isn't it? So that is basically because of the presence of Tyndall effect. So what is present in the atmosphere? There are very fine particles, gas molecules obviously you cannot see, but there may be some dust particles, water molecules. So when light falls on these particles, it is capable of scattering and therefore you will be able to see. Is that okay? Yes. Why does it happen? Why does the solution not show you Tyndall effect? Come on, answer the question. Why doesn't the solution?
It doesn't have like the particles of like it have the particle, but it is very small in size as compared to the the solution.
Okay, what else should you say? That's only part of the answer. My question is, why is Tyndall effect seen in a colloidal solution and why it is not seen in a homogeneous solution? What else can you add?
Like colloidal, there is a lot of particles in colloidal solution.
Lot of particles?
Then the particles
Collide
are
are
very short,
uniformly
bigger.
The
And the particles present in the colloidal solutions are scattered around uniformly through because of which we can see the Tyndall effect in the colloidal solution, whereas in the
So
homogeneous solution,
what is this Tyndall effect?
It appears
passing of light through
Yes, you have to tell. When you pass light through a colloidal solution, what is happening to these particles? These
just
particles
as
are
a way to
catching
make
the light
wave
and therefore you can see. Did you understand? So these 2 points have to be given. Mark it as important. Tyndall effect is important. Something or the other will be asked regarding Tyndall effect.
Tyndall effect can be observed when sunlight passes through the canopy of a dense forest. In the forest, mist contains tiny droplets of water, which act as particles of colloid dispersed in air.
Okay. So now we are going to discuss, just as we have written for suspension, 4 or 5 points, properties of a colloid. We have read that properties of a colloid. There are about 4, 5 points. Let's see what we have to write. What are the key words I want you to identify?
Properties of a colloid. A colloid is a heterogeneous mixture.
So what is the key word here?
Heterogeneous
Heterogeneous mixture. So write down quickly. Point number 1. Your heading will be properties of a colloid. First point, heterogeneous mixture. Second point, size of particle is too small.
particles are too small to be
Yes.
seen.
By the naked eye. So with the naked eye, you cannot find out.
Second point,
Particles
Are
are
very
very small. We see with the naked eye. Kaushik, how will you modify the third point? Abhishek, how will you modify the third point? You don't have a textbook, no, you are having the all you see it.
It's the same.
I want one word,
colors are big enough.
third point.
Ma'am, they are big enough to scatter a
beam
beam
of
of
light.
light.
What is it called?
Tyndall effect.
That's okay. One word you can say, Tyndall effect is seen. Isn't it? But in the examination, you have to write down what is Tyndall effect. But you should remember the Tyndall effect is seen. Particles big enough to scatter the light, etc. Then,
They are very stable.
yes, stable. Keyword is stable. What does it mean?
And they don't settle down.
What they instead of writing
The
they
colloid particles
Particles.
don't settle down.
correct. The colloidal particles do not settle down, or in other words, they are stable. Last one.
Centrifugation.
Can we separate out the
Can be
particles?
separated by the process of centrifugation.
Okay, what about suspension? How did we separate it?
Filtration.
Filtration. We cannot use filtration here. If you take a filter paper and put, the whole thing will come out because the particles are so small. So how can we separate? Separated by not by filtration,
Centrifugation.
Centrifugation. given the diagram.
Yes.
I will show you next time. Basically, what happens is they are taking a test tube, okay, and you are putting your colloidal solution. Look here, and there is a disc like where you put all the test tubes, and it spins at a very fast rate. You have probably seen
And
it.
then let's settle some.
Yeah, so the heavier particles, let us say of whatever it is that we want to settle, that begins to settle down. What remains is the clear. Okay. Now let us see the last paragraph. Where are we using this process of filtration? Sorry, centrifugation. Read the last paragraph.
The components of a colloidal solution are the dispersed phase and the dispersion medium. The solute-like component are the dispersed particles in a colloid form.
It can be separated by centrifugation.
The dispersed phase, and the component in which the dispersed phase is suspended is known as the dispersing medium.
So there are two words that you should remember. What are they? Dispersed phase and dispersed medium. Okay? It is dispersing medium. Dispersing medium is the medium in which, and the particles which are present there is known as a dispersed phase. Okay?
Colloids are classified according to the state, solid, liquid, or gas, of the dispersing medium and the dispersed phase. A few common examples are given in table 2.1. From this table, you can see that they are very common in everyday life.
Is that okay? So what are the two things that we should remember? One is the dispersing medium and the dispersed phase. So we can say it is a solid or a liquid or a gaseous depending upon the dispersing medium. Now, I want you to look at this table which is given here. One of you can see this table?
Yes, sir.
Okay, look at the first one. We have got liquid and gas. You have got liquid and you have got gas. What is the first thing that we have taken? Dispersed phase. Okay, so the first one is your dispersed phase, and this is your dispersing medium. We have got the dispersing medium. Now, one of the first examples that they have given it is an aerosol. For example, cloud and solid. Aerosol is basically you're talking about a gas which has got which is present in a liquid. So that becomes an aerosol. For example, here they're talking about clouds.
Sorry, even oxygen is an aerosol, as it is present in water and it is present in water.
Yeah, so but here it is liquid. We have taken liquid as seen a cloud. Basically, what is happening is you're having water droplets, and it is a gas which is present in a liquid droplet. So basically, this is an aerosol. Now look at the next one. So it is a solid and gas. Example of a solid and a gas. Okay, so this is also an aerosol. Did you see that it is an aerosol? And one of the examples that we are talking about is smoke which is coming out from the vehicles, or the smoke which is coming out through the chimney. Okay, so what is there? Which is the solid phase here? It is the fine carbon particles which is present inside the gaseous medium. Did you understand? So it is a dispersed phase which is present in a dispersed medium. Next one. What is it? Gas in a liquid. So you have a gas in a liquid, and the example that they have given here is foam. Right? So shaving cream, that's one of the examples. Similarly, you have seen liquid in a liquid, which is an emulsion, which is milk, is an emulsion, or whatever it is.
Like water is it?
You know, water is an emulsion.
Which one?
Now liquid. Is water and
No, it is not. We cannot. Water is pure water. H2O is pure, it's compound. Now we are talking about mixtures. Did you understand that? Water is consisting of H2O, which is present in a fixed composition. Here it is a mixture.
So any mixed heterogeneous colloidal.
And these are the ones. So these are all colloids, examples of colloidal solutions. Okay. Then the next one, of course, is solid in the liquid, which is basically a salt. Mud, milk of magnesia, blood. Blood is also an example here of a salt. Then gas in solid, once again, they are given as foam. foam, rubber, sponge. Okay, did you see that? The last but one, you are having a liquid in a solid, which is a gel. And the last one, of course, is a solid and solid. This is an example where you are talking about colored gemstones, making glass, etc. Even an alloy can be considered as a last example where it is a solid which is dissolved in another solid.
Now, if we put, maybe if we put a fruit, like few drops of food coloring in a glass of water, could it be classified as emulsion?
Yeah, it could be probably. You are talking in terms of, let us say, what is dye, what is a food coloring? It is nothing but very small fine particles of solid particles. So it is nothing but solid which is dissolved in a liquid. Okay, so solid in liquid, you can tell it is either gel or probably it can also be an emulsion. It could be an emulsion also. Okay, it is a form of it. Okay, okay. Are you okay till now?
Yes.
Okay. So examples which are present in the table there gives you an idea that these are the colloidal, day-to-day substances which are present in the colloid. Yeah. Now we have got, since we are talking about mixtures, it becomes very easy for us to understand how are we separating the mixtures. Two things we have already discussed. What was the
Filtration and
first one?
centrifugation.
Filtration, centrifugation. Did you mention that word centrifugation?
Yes, ma'am.
That is also an important word. Okay. Now let's see the examples here. What is the one of the examples which is given there?
Common H20, common example.
What is activity 2.4? What is it telling us? How can we obtain?
What are the types of
Luxury.
cloth?
Luxury.
How can we obtain colored component which is the dye from blue or black ink? No, which is
We find that ink is a mixture of dye and water. So
okay, yeah, yeah, it is different in your textbook. It is different in yours. Oh, they have downloaded so many things. Everything they have
I mean, it's in volume, but not in.
It's not very
Also good for us or bad for us?
Bad models in a way.
in a way, because you're not learning so many things. Yeah, it was given so many of them.
Yes, so we have
You
reference.
can explain from this textbook.
Yeah, I will do that. No problem.
Then we will-
All this is not there. Everything has been cut out. Very good.
Now, कितने minutes लगा?
Hey, let's.
So many things. Basically, we are just talking about how we can separate out different type of mixtures. Okay,
we will do.
I'm just telling you. I will not do it in detail, and since it's not in your textbook, it's something that you may know. Okay. For example, now they have said, how can we separate cream from milk? Buttermilk. Okay. What does mommy do? She will churn it. So by churning, what are we doing? We are separating out. So that is nothing but a mixture. Correct. Suppose another example. I'm asking you about. Abhishek, tell me. Suppose I give you a mixture of oil and water. Can you separate it out?
Yes, ma'am. Yes, ma'am.
How can you separate it out? By not the centrifugation.
And we will just take.
Okay, I'm giving you kerosene and water. Which will be at the top, which will be at the bottom.
Kerosene at the top, water at the bottom, we can set down to kerosene and like.
What is it? Why is it? Why do you get to separate?
Lighter.
Like,
Use the word. Use the correct word. I gave you some words to take. Density
density.
based on density.
Yes, yes.
So anything which has got less density will go at the top. Anything else?
Ma'am, and then we can use it for it.
Easily you can do it, or probably you're using what is known as a separated part. So basically, there was another thing, a very interesting concept of fractional distillation. Fractional distillation. Okay.
Kind of word.
Yeah, you have heard. That's what happens, when they're cancelling out so many pages. By the
How
time,
many pages?
it's about 3 pages.
The diagram is also
So,
not.
so many diagrams, but it is there in your volume. Abhishek, show me your volume. See, but it is given in your volume, okay? See here. How can we obtain different gases from there? How can we separate different gases?
Ma'am,
Yes, ma'am.
no test because
Actually, in test it will come in school test.
Ma'am, it will come in tutors.
Whatever is there in the text.
Maybe.
Whatever is there in the text. Okay, let me just tell you about fractional distillation. The word fractional distillation just tells you that each of the components, let's say for air, okay? Now air itself is a mixture, and this mixture consists of various components.
Oxygen, nitrogen.
Nitrogen, you have got oxygen, etc., and various other gases. Now suppose you want to separate it out, there's going to be a process. So what are we going to do? We are first going to cool it. So when you cool it and also increase the pressure, the gaseous form is getting converted into a liquid form. Okay, it becomes liquid air. Listen to what I'm saying. It becomes liquid. Okay. Now what is happening is you're slowly increasing the temperature. Let's say I'm just giving you some numbers. So you have first decreased the temperature. Now it is at 0 degrees. So we're going to decrease it further till it becomes, let us say, minus 200 degrees. Some number I'm giving you. Okay. So at this temperature, all these gases are now present in what form?
Liquid.
They are all present in the liquid form. Now I'm going to slowly increase the temperature. Okay. Each one of them as a gas is slowly getting converted into, okay, the liquid form is once again getting converted into a gaseous form. So at one temperature, one of the gases will come out. As you're increasing, another one will come out. As you're increasing, another gas will come out. So you are able to collect the fractions.
And
this is known as
separation of liquids and gases based on the temperature, based on their boiling point.
Exactly. What is this conversion from liquid to a gas? It is based on the boiling point.
Petrol was separated by.
Correct. So this is your fractional distillation.
And we can like convert petrol to gaseous form.
Yeah. Petrol.
Gaseous form. Very good.
Here what is happening now? Petrol is what it is in the liquid form. So you are taking crude oil. Okay, crude oil is nothing but a mixture of petrol, hydrocarbons, gasoline, turpentine, etc., etc. Okay. So this oil is now gradually heated. Oil is heated so that it turns into a gaseous form. So it is the same thing here, but instead of decreasing to this temperature and then increasing, we are already having all of them in the gaseous form. So you are slowly increasing the temperature. Maybe at 25 degrees Celsius, you will have
Gas
one
will
fraction.
come out and
Yes.
get to the
As
top.
you are increasing, maybe at some other temperature, maybe at 37, some other thing will come out. As you are increasing. So as you are increasing, the liquid is getting converted into gaseous form. Once these gases are formed, it can be condensed. It can be separated. Did you understand this process? So that is basically what is known as fractional distillation. Now I want you to do something for homework. One homework, come, give me your textbook. Give me the textbook. Come on, mark it everyone. They are bad for completing homework.
They are bad for not completing homework.
Please mark exercise number 1. For homework, so write it down.
Ma'am, too many.
Hey, it is easy. How to separate this one word?
Just write federation,
Yeah,
certification.
That's all. Just read it, try to understand.
Yes.
What? You do that?
Yes.
Yeah.
They won't do that. Just copy.
Now what do you have?
That's homework किया. तो कौन बोल रहा है भाई? मैंने किया. हाँ.
You people have finished some test in the school.
No ma'am.
Yeah.
School test and all.
Ma'am in July I could be.
August.
Okay,
First
very
one you
good.
want? Second one.
Very look at that copy now.
Yes ma'am. See,
No.
you should be ashamed.
No. Homework is basically given for you to improve.
मैम ने मना किया. क्या अरे अभिषेक ले लो, अभी कोई नहीं लेगा.
आज में क्या क्या हुआ?
भाई मैं सोच रहा हूँ मैम आगे सुबह क्या नशे में सुबह दिमाग खराब हो गया और इस किसी को पढ़ना चाहिए पढ़ जा अलग